Dr. Memari with the new experiment, nitration of methyl benzoate. I want to make sure to mention here that the pre-lab discussion for this experiment is going to cover the theory for this experiment. The purpose of this experiment is to introduce the reactions of aromatic compounds that they already have one substitutions on it as either electron donor or electron withdrawing group. If it's electron withdrawing group, is going to be methyl director. If it's electron donor group, is going to be ortho-para director. Well, I always tell that if you already know this in theory, what's the purpose of doing the experiment in the lab? You know that methyl benzoate carries a electron withdrawing group, so the product is going to be methyl. When we perform this experiment in the lab, when the final product needs to be confirmed. So when first we are going to measure the chemicals, mix them, and when we mix, we find the final product. We isolate the final product, cleaned or wash, dry, because it's going to be, in this case, it's going to be solid compound. Measure the melting point, and using the melting point, we're comparing to the three possible product of ortho, methyl, and para of the final product. We can compare the product is methyl. But watch the pre-lab discussions. I would actually write the formulas. You could see how the explanation and the formula or chemical reactions for this experiment. Let's go ahead and measure the chemicals. I'm using very low concentration or I am using very low volume or low quantity of the chemicals. For obvious reason, we are dealing with concentrated nitric acid and dealing with concentrated sulfuric acid. I don't want to use like 5-10 milliliters of this compound to make the point that we can get methyl or ortho-para. So it's very close to micro scale. Going to label two test tube A and test tube B. So you could use like a labeling tape or a marker to label your test tube A and B. In test tube A, I'm going to measure the quantity of methyl benzoate dissolved in sulfuric acid. Following the procedure, we are going to add 1 milliliter of sulfuric acid. For 1 milliliter, you have the choice of using automatic pipetter, which I know for this lab setting at this time, we don't have enough of those to be used by students. And the other choice would be using 10 milliliter graduate cylinder, measuring 1 milliliter. By the time you transfer, most of it stays in the graduate cylinder. So because a 1 milliliter is about 20 drops, 20 to 25 drops based on the size of the droplets that you are using or you're putting. I'm going to count 20 drops of the sulfuric acid for measuring 1 milliliter. So I'm adding 1, 2, 3, 4, 5, and the sulfuric acid, before mixing with the methyl benzoate, I place in the ice for it to cool down for about like 3 to 5 minutes for it to cool down before I add the methyl benzoate. For test tube B, I'm using 0.5 milliliter of nitric acid with 0.5 milliliters of the sulfuric acid. So I would do the same by counting 10 drops of each. This test tube, 2, 3, 4. That's 10 drops. This test tube basically is going to prepare the nitronium ion, or would generate the nitronium ion, which is the strong electrophile used in this reaction. The reaction is electrophilic substitution type reaction. So as a nitric acid, 1, 2, 3, 7, 8, 9, 10. So you can just trust me that I did count the 10 drops of each and place in test tube B. I'm also placing the test tube B in the ice. Now, to the first test tube that contains the sulfuric acid, I'm adding 0.4 milliliters, which 0.4 milliliters at this point is going to be 8 drops of the methyl benzoate into the sulfuric acid. Basically, I'm dissolving methyl benzoate inside the sulfuric acid. 2, 3, 4, 5, 6, 7, and 8 drops of the methyl benzoate. I will place it back in the ice. Why are we using the ice bath in this case? Because we want to make sure that the reaction mixture separately are going to be cooled to like a 5 degree. By placing the test tubes in ice for 3 to 5 minutes is going to assure that the temperature is going to stay low. And one other thing that we have to follow based on the procedure is that we're going to add 1 drop of the mixture, like the nitronium ion mixture, into the methyl benzoate at the time. We wait about 20-30 seconds before we add our second drop. The reason for that is this reaction is going to be exothermic reaction. It's going to generate heat. If the temperature goes up at a higher temperature, the product is going to be basically contaminated because the reaction will generate byproducts of dinitro or trinitro methyl benzoate. So to avoid that, we are going to add it slowly. I mean, some like yellow color is fine, but if you see the product or the mixture is going to get like a dark orange or brown color, it's best to start again because you don't want to have the byproducts of dinitro or trinitro. So I may sometimes, because it's long, wait for making sure that the reaction mixture is cold enough. I might pause the video and then I go back. Just keep in mind about 5 minutes separately. They are going to stay in the ice to make sure that it's going to cool down. Then going to use this micropipette and add the nitronium ion, which is the test tube B. The content of test tube B, 1 drop at a time, into the test tube A, which is my methyl benzoate. And wait 20 to 30 seconds in between addition of each drop to assure that the reaction temperature doesn't go high to produce the byproduct.